Hello, my name is Hilary Weller. I work in the Department of Meteorology at the University of Reading. And meteorology is all about predicting the weather and the climate. And this video is about how we use maths and computing to predict the weather. Well, it's a introductory video on this. It hardly covers the subject. It's suitable for children aged, say, 9 to 13. Perhaps, and it includes a scratch programming exercise in making a weather forecast, a simple one, obviously. So how do we use maths and computing to predict the weather? Oh, I should say also there's a worksheet that you can print out to accompany the video. First of all, how is a weather prediction made? This is a recent weather forecast from the UK Met Office, and it starts off with saying what's been happening earlier. These lights, the lines here are lightning, and these colours are the rain that's coming across, and you can see the lightning and the rain moving, and then it switches to a forecast. We can see in the forecast we can see wind and cloud cover and the rain, so it switches from what's been happening in the past to what's been happening in the future. So how do they use what's been happening in the past to predict what's happening in the future? Well, first of all, there's getting all those observations in of the recent weather, and millions of observations of weather from around the world are sent to forecasting centres like the UK Met Office. And this is a thermometer measuring the temperature of the air inside a Stevenson screen. This Stevenson screen is used so that the sun doesn't shine directly on the thermometer, which would warm it up, make it much warmer than the surrounding air, and also so that the wind doesn't blow over it and which might cool it down to cooler than the surrounding air. We don't want to measure the temperature just at the surface. We need to measure the temperature throughout the depth of the atmosphere. So weather balloons are launched in order to measure the temperature in the upper atmosphere. This is a weather balloon which measures the temperature in that little box that's hanging from the weather balloon, and it sends it in a radio signal back to the Earth. This is an anemometer which measures the wind. This cup anemometer here measures the wind speed, and this bit measures the wind direction. We also want to know the temperature of the sea surface. The temperature of the sea surface is very influential on the weather that comes in to land from the sea. So this is a traditional way of measuring the sea surface, but in fact it's still measured like this. So you throw a bucket over the side and get some seawater and put a thermometer in it. In fact, I've been on a sailing ship where we did this. So I've done this, which was exciting, and it's still done by merchant seamen and around the world. Although it's more often they use engine intake to measure the sea surface. But of course, the weather forecasts have become so much better in the past few decades because we've got observations from satellites which get an incredibly detailed view of the Earth. They can measure cloud cover, temperature, and wind speed and direction. So all this data is put together to get a picture of what's been happening over the past few hours. And this animation shows the clouds moving, and arrows show the wind speed and direction. So the longer arrows show stronger winds. So that's what's been happening in the past. What's going to happen next? What is the forecast? We're going to have a think about how forecasts are made. First of all, just some simple thoughts about it, and then write a code to generalize this. So if we observe that the rain is 10 kilometers away and it's moving towards us at 10 kilometers per hour, when will it start to rain? How long have we got until it rains? Well, that will be an hour. If we observe that the rain is 20 kilometers away and it's moving towards us at 10 kilometers per hour, well, now it's going to take 2 hours until it starts to rain. If the rain is 12 kilometers away and it's moving towards us at 4 kilometers per hour, how long until it rains? It's 3 hours. So these are quite simple questions, but we need a formula so we can get a computer to do this for us. What is the formula? The formula is that the time it takes is the distance it is away divided by the speed. And in Scratch, and in other computer programs, that divided by is written slash. There is an operator to do this. In order to do these calculations in Scratch, we're going to need variables. I'm going to come back to this description of variables in a minute. And first of all, I'm going to talk a bit more about the overall Scratch assignment. So you're writing a weather forecasting code in Scratch. You have observations of where the rainfall is and how fast it's moving. You need to write a Scratch code to calculate when it will start to rain. So you can start with something like this. First of all, you ask how far is away is the rain, and you set the variable distance to the answer. You ask how fast is the wind blowing towards us in kilometers per hour, and wait. And you set the variable speed to the answer that you get. And then you set the time it'll take to rain to the formula that I gave before by using a Scratch operator. And then you can say it will rain in time hours. So a bit more about these variables that I've been talking about. For this code, you'll need to define 3 variables. And variables are bits of memory in the computer that store a number. So we'll give these names: distance, speed and time. And variables can be created by going to data and choosing make a variable. And then you type in the variable name that you want to use. And then you can choose set from data to set the value of the variable either to a number or to an answer that you ask, answer of a question that you ask, or to an operator. Once you've got this code working, you should test it a bit. Testing is a very important part of programming. And then you can make some further developments. Here's a list of improvements you could make to your code. And hope you enjoy doing this weather forecasting. That's all from me.